Hi everyone, welcome back. We're going to cover another conic called the ellipse. So the ellipse is the set of all points in a plane, the sum of whose distances from two distinct fixed points, called the foci, is always going to be constant. So here are the 2 points, the plural focus is foci, and you can see that we have D1 and D2, and D1 plus D2 will always be constant. That string length is going to stay constant, and we're able to draw the ellipse as a set of all those points. Now let's go back here. So still going to have a center just like we have for a circle, but there's going to be 2 axes. The longer axis is the major axis, and the minor axis is going to be the shorter axis. The vertices are going to be on the major axis. So we have a vertex here and a vertex here on this major axis. And on the minor axis, we're going to have co-vertices. So that would be a co-vertex up here and a co-vertex below. If the point is on the major axis, well, we know that D1 is going to be the length of A plus the length of C. We will know that D2 will equal the length of A minus C. So here we have an ellipse. If I move the point to the major axis, we can see that the 2 lengths, the A plus C and this length, A minus C, will equal the length of the major axis. Now let's consider how we incorporate B and C. We can make 2 right triangles, both with the length of C and a side length of B. And we know that this will be the hypotenuse, and 2 lengths of the hypotenuse will equal the length of the string, which we just said was 2a. We can derive the relationship between a, b, and c as b squared plus c squared equals a squared. If the major axis is horizontal, meaning it is a wide ellipse, then a squared will be under x minus h quantity squared. If the major axis is vertical, a squared will be under y minus k quantity squared. For example 1, we're given that the foci are negative 2, 2, and 4, 2, and the major axis length equals 10. And we need to find the standard form of the equation for this ellipse. Well, given that the coordinates are negative 2, 2, and 4, 2, you can tell right away that this ellipse will be horizontal. So if it's horizontal, we know the equation will be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now to find the center, well, we just have to find the midpoint between the foci. So that will be 1, 2. Since we're given the major axis length is 10, we know 2a equals 10, or a just equals 5. And we can figure out c just by looking at the picture. So c equals 3. B squared equals a squared minus c squared. So b must equal the square root of 25 minus 9, which equals 4. The equation will be x minus 1 squared over 25 plus y minus 2 squared over 9 equals 1. We know the center and the focus will have a distance of 3. We know that the value for A is 5, so we'll have this value for A, and the value for B is 4, So that's going to be 4 units above C and 4 units below to find the co-vertices. And we could draw the ellipse. All right, let's go to example 2. To write the equation for this ellipse, we'll have to complete the square. So 9x squared plus 36x plus 4y squared minus 8y will equal -4. Before we complete the square, we will need to factor. 9 can be factored out for the first two terms, so 9 times x squared plus 4x, and 4 can be factored out of the next two terms, so it's y squared minus 2y equals -4. Now remember, to complete the square, we're going to have to divide b by 2 and then square it, but in actuality, we're adding 36. And for y, we're adding 4 to both sides. So this will factor into 9 times x plus 2 squared plus 4 times y minus 1 squared equals 36. Now we can divide both sides by 36 to write the equation. So we'll have x plus 2 squared over 4 plus y minus 1 squared over 9 equals 1. Now we can easily see the center will be -2, 1. So that means our A is 3. So we'll go up 3 to -2, 4, and down 3, -2, -2, and those will be our vertices. We know that B will equal 2, so if we go 2 to the right, that will be 0, 1, and we go 2 to the left, that will be -4, 1. So the vertices are -2, -2, and -2, 4. The co-vertices are -4, 1, and 0, 1. Or C will equal the square root of a squared minus b squared. So that will be the square root of 9 minus 4, which equals square root of 5. We will add and subtract square root of 5 to the y value. So we'll have -2, 1 plus or minus square root of 5. So it'll be about 3.2 and -1.2. Okay, I'd like you to try example 3. So pause the video and come back when you're done to check your answer. Okay, checking your work, you should have the equation x minus 1 quantity squared over 25 over 16. Just be careful, we're dividing both sides by 25, so remember a squared will be 25 over 16. And then we'll have y minus 1 squared over 1. Knowing the a squared is under the x, we know that this ellipse will be horizontal. Given the equation, we can find a, which is 5/4, b, which is 1, and we can calculate c, because that's the square root of a squared minus b squared. So we can put those all together to find the center, foci, vertices, and co-vertices. For our last example, we're going to look at the moon. The moon travels around Earth in an elliptical orbit at one focus, which is shown below. The major and minor axes of the orbit have lengths 768,800 kilometers and 767,640 kilometers. We want to find the greatest and least distances from the Earth's center to the moon center, which is the apogee and the perigee. So the apogee is going to be the length a plus c, and the perigee will be a minus c. So 2a will equal the major axis, which is 768,800. So our a will be 384,400. The minor axis is 2b, so we set that equal to 767,640. So b equals 383,820. And remember, c is the square root of a squared minus b squared. So that's about 21,108. So to find the apogee, we just add a plus c. So that will be about 405,508 kilometers. And the perigee will be a minus c, which is 363,392 kilometers. Well, we learned a lot today about ellipses, and we will go over more problems together in class.